All right, everyone, welcome to section 7.5. This is Nick Jacobs, your intermediate algebra instructor here at Yavapai College. We're going to talk about complex fractions today. So we're going to introduce complex fractions, and then we're going to simplify complex fractions as well. So what is a complex fraction? Well, it's basically a rational expression that contains fractions in the numerator, denominator, or both, okay? So basically they involve division of fractions. And when you divide two fractions, as we also have talked about earlier this chapter, we can multiply one of the fractions by the reciprocal of the other one, basically. So we multiply the numerator, which in this case could contain a fraction, by the reciprocal of the denominator, which also could contain a fraction. So that's a complex fraction. So how do we simplify them? So this is, again, just kind of the algorithm here that we use for going through this, but, we take a fraction, and when we divide it by another fraction, we multiply by the reciprocal. And we've seen this, right? So again, I could also write this, let me actually get a different color here. So I could write this as A over B divided by C over D. And then again, we learned that keep it, change it, flip it a few sections ago. So we keep the first fraction, change division to multiplication, and then flip the second fraction. Okay, so we've kind of seen this, and this is just another way to write out this same thing here. Okay, so I am going to go through two methods of simplifying complex fractions, and just feel free to use whichever one that you would like. Okay, and I'll include examples of some of the ones that may be a little bit more difficult in your homework, just so you get a kind of more of a holistic view on this, especially if you're going into another math class after this. So method one, okay, so to simplify a complex fraction, what we're going to do is we're going to do the following steps, okay? So we're going to write the numerator as a single fraction. We're going to write the denominator as a single fraction. Okay, and really this purpose of single fraction, okay, is very important because it may require that we do stuff like last section, where we take two rational expressions and we either add or subtract them together to make a single fraction first. And we'll see that here in one of our examples. And then we're going to divide the numerator into the denominator by multiplying the numerator and the reciprocal of the denominator. So again, keep it, change it, flip it, basically. And then we're going to simplify the result into lowest terms. So let's kind of see what this looks like here with some complex fractions. So this first one, we have kind of seen an example like this, again, a few sections ago. But what I like to do for these is I like to write them out like this. So I'm going to take my first fraction, my numerator, 5, 6, and I'm going to divide it by that 2/3. Okay, so I just rewrote the problem, basically. And then what I'm going to do is I'm going to change the division to multiplication. So I keep the first fraction and I multiply by the reciprocal of the second fraction. Okay, and then at this point, what we can do is we can simplify it, maybe by canceling out common factors. So we see diagonally here that 3 and 6 have a common factor of 3. So I can cross the 3 out and make that a 1, and I can cross the 6 out and make that a 2. Again, another way to think about that is dividing both of those by 3. So then what I have is 5 times 1 divided by 2 times 2, which is 5/4. Okay. Another way to think about this step, again, as we've seen in earlier sections, is, you could break up the 3 and the 6 into kind of primes there. So 6 is 3 times 2, 3 is 3 times 1. And then again, we can cancel out the 3's here, basically to get the same thing. So I just did, basically the same thing here, just a slightly different method, just so you can see how that cancellation works. So that one was kind of review. So now we're going to put in some some variables here and into these rational expressions here. So let's rewrite this. So we have x over 10y divided by x over 15 y squared. So again, all I'm doing there is I'm rewriting these. I just like this form a little bit better. Okay. And then I'm going to do that whole keep it, change it, flip it thing. Keep the first fraction, change division to multiplication, and then flip the second fraction. And then from here, what I can do is I can again look for any common factors. So I see I have an x and an x. Okay. Can cancel those. I have a 15 and a 10, so I can go ahead and divide both those by 5. So 15 is going to be 3, 10 is going to be 2. 2 there, sorry, that's a 2. And then we have a y and a y squared, where I can cancel out one of the y's there. So basically, all I have left is a 3 and a y on top and a 2 on the bottom. Okay, now let me just show you again how that cancellation kind of worked here, in case you're wondering a little more. So I can break the 10y up into 5 times 2 times y. I can break the 15y squared into 5 times 3 times y. And then again, what you're doing is you're looking either straight up and down or diagonally to be able to cancel those common factors. So I can cancel an x, I can cancel diagonally the y, I can cancel diagonally the 5, and then again, I have the 3 times the y over the 2 left over. So these get a little bit more complicated than that. This is a homework problem. Again, your numbers might be a little bit different, but again, kind of going back to, how to do this first method, what's really important is to write the numerator and denominator as a single fraction. Now we can see here in this complex fraction, our numerator is just x, so that's fine. But our denominator is 7 over x plus 7 over x. And we want to make this denominator into a single fraction. Okay, so not with that plus in there. So what do I do? Okay, well, first of all, let's rewrite this. Okay, so this is really x divided by this entire denominator. Okay, and again, I can't flip this until it's a single fraction. So what do? I'm going to add these two together. Now we saw in a couple sections ago that you can add these when you have a common denominator. So you need a common denominator to add and subtract. You do not need a common denominator to multiply and divide. But the thing is, if you're dividing in here, what you want to do is you want to get this guy, you want to get rid of the adding, okay, or subtracting. So let's go ahead and do that. And this one's really easy because this has a common denominator. Next example, we'll have one without a common denominator, but here we go. So what is 7 over x plus 7 over x? Well, it's just simply 14, right, over x. So we add the numerator and keep that denominator. And then from here, we can do that whole keep it, switch it, flip it. Now, if you want to, you can write x as x over 1, if that really helps you. And then change division to multiplication, and then flip this second fraction and do its reciprocal. So that becomes x over 14. Now I can go ahead and multiply straight across. X times x is x squared. 1 times 14 is 14, and that is all. So this one, again, combined a little bit of that knowledge of, we need to get these as single fractions. Then we can use that, make division into multiplication and multiply by the reciprocal. But let's do an example where we do not have common denominators. So in this one, okay, we see that we have in the numerator 3n minus 1 over 3n. The denominator is 3n plus 1 over 3n. Sorry about that. I was just wondering about these three n's, but anyway. So what we want to do here is, again, if you want to, we can go ahead and write this as it's 3n minus 1 over 3n. It's that entire thing, okay? And it's being divided by this thing, your denominator, okay? And the only thing is I cannot divide these yet because I have that subtraction and addition in here. So these things in parentheses, our numerator and denominator, need to become a single fraction. Well, let's go back to last section when we added and subtracted with unlike denominators. We need to get a common denominator here. So the first thing we do is we need to find an LCD for these things. And what does the LCD equal to? Well, in this one, if I put 3n over 1, our denominators are 1 and 3n. My LCD is just simply 3n. So what I do is I take this 3n, if you want to put it over 1, you can, and I multiply it by 3n over 3n, right, to get that common denominator. And then this other part here, the 1 over 3n, I don't have to do anything with that, okay? So then our numerator here is going to become, well, 3n times 3n is 9n squared over 3n minus 1 over 3n. And that is just n or 9n squared minus 1 all over 3n. Okay, so that is our numerator. That's just this part, the 3n minus 1. Now it is a single fraction. I'm going to divide it by our denominator. I need to find that. Okay, so in this guy, what is your LCD? Well, it's also 3n. Okay, so our LCD is also equal to 3n. So what I do is I take my 3n over 1 and I times it by 3n over 3n. And then I just have that plus 1 over 3n. So I don't have to do it for that one because it already has that common denominator of 3n. And what do I have? So I have 3n times 3n is 9n squared again over 3n plus 1 over 3n. And now, since I have a common denominator, I can go ahead and add the numerators. So I have 9n squared plus 1 on top and 3n on the bottom. Now that these are both a single fraction, okay, it's something over something, okay? The only addition and subtraction I have is located within a numerator, okay? And this one I had two different things, okay, with this rational expression. Now I can go ahead and change this division and multiplication and flip this second one. So let me write that here. This is going to be 9n squared minus 1 over 3n times the reciprocal of the second one. So 3n over 9n squared plus 1. And we can see here that the 3n's cancel out. Now, you might notice that 9n squared minus 1, that is a difference of two squares. Okay, but we don't have anything that's the sum of two squares. So I can't really simplify this anymore. Okay, that's all that I can really do for this one. Okay, now if you want to, you can take this numerator here and you can write it as your difference of two squares. But the only thing is your denominator is going to stay the same. It's going to stay that 9n squared plus 1 because there's no such thing as a sum of squares. There is a sum of two cubes, okay, but not a sum of two squares. So this could be an answer, and also this could be an answer as well. Okay, now I'm going to show you method 2 for simplifying these complex fractions. So the second method is to first find the LCD of all of the fractions. Okay, find the LCD of all of the fractions within the complex fraction. Excuse me. And then we're going to multiply the numerator and the denominator of the complex fraction by the LCD. Excuse me here. So again, find the LCD of all of them, and then we're going to multiply each term within the numerator and denominator of that complex fraction by the LCD, and then we're going to simplify it. So let's kind of see what this looks like. I'll also show you later that homework problem that we did earlier with this method. So In this problem, we have 1 over x plus 1 over y all over x plus y. Now, what you're going to do is the first step is you're going to ask yourself, what is the LCD of all of the denominators here? So you have a denominator here of x. You have a denominator of y. What's the denominator of x here? Well, it's just 1. And same thing with y here. So what's your LCD of all of those denominators? Okay, well, the LCD here, again, is basically all the factors of those. So it would just be 1, x, and y, or just x, y. So the LCD is equal to x, y. And let me actually erase. So I'm going to erase everything that I circled there. And so what you do at this point with this method is you take this whole numerator, the 1 over x plus the 1 over y, and you multiply it by that LCD. And then you take this entire denominator and you multiply it by the x over y, or sorry, the xy. Okay, so what happens here? Well, when we do this, we need to distribute this xy in here. Okay, we're not going to distribute it down here because I don't have any rational numbers here. Or I mean, I don't have any rational expressions. But let's multiply the xy into the 1 over x. That just gives me xy over x. And then multiplying it into the 1 over y, that gives me xy over y. Okay, and then that's still all over this denominator of xy times x plus y. Now, what does that do for us? Okay, well, basically, that allows us to cancel within these rational expressions. So you see now in this particular rational expression, xy over x, I have 2 x's. So I can cancel those out. And here I have xy over y, I can cancel the y's out. So basically, all I have left here is a y plus an x. And that's over xy times x plus y. Okay, now we know that y plus x, okay, I can write that as a parentheses, right? That's a single expression, just like it did this x plus y. I can flip the x and the y around. So really this is x plus y over x y times x plus y. And that just allows me to be able to see this cancellation more easily, that I can cancel out these x plus y's. Now, what am I left with in the numerator? Well, I could have multiplied this by 1, right? So I'm left with a 1 in the numerator over x, y. Now, okay, I'll just make a brief comment here that, yeah, these are a little bit tricky. Okay, they take some practice, and that's what the homework is for. Okay, so really take your time with these, write them down. If you don't get the steps, try another example, right? There's always more practice on your homework. And look through the steps of those homework examples. Okay, and make sure that you know all the steps, that you're writing down all the steps. Now, I don't remember what method the homework uses in my lab, but again, try to pick the method that works best for you. Okay, so let's do another example here. This one's going to be a little bit more difficult. So we have our LCD. Okay, we have to find the LCD in method 2 of all of your denominators. So x minus 1, x minus 1, and x. What's the LCD? Well, it's just all of those factors. So it's x times x minus 1. Okay, so that's your LCD. And then what you do is you take that LCD and you multiply it by both your numerator and your denominator. Okay, so here's the numerator. Okay, I multiply it by the LCD. Here's your entire denominator. I multiply that by the LCD. And this is going to take a little bit of time to write out here. So now we distribute this in here, both on the top and the bottom. Okay, we distribute it to the numerators. So I have 4 times x times x minus 1 over the x minus 1 minus 6 times x minus 1 over x all over 1 times x minus 1. I'll just write it as x times x minus 1 over x minus 1 plus 8 times x minus 1 over x. Okay, now notice I did not multiply this with the denominators. Okay, and there's really no reason, because when I'm multiplying it, I'm multiplying this as x times x minus 1 over 1. So when I multiply it in there, the denominator is just getting multiplied by 1. So I'm not really doing anything with that. Okay, same thing down here. Okay, this is x times x minus 1 over 1. I'm multiplying the denominator by 1. So that doesn't change the denominator. Now what I do here is I cancel any factors that I can cancel. Well, that's the reason I did this, okay? So that I can cancel out all of these fractions basically. So I can cancel out the x minus 1 here. So I'm left with a 4x. I can cancel out the x, okay? Don't touch this x because it's in parentheses. This is an x minus 1. I cannot just cancel an x that's being subtracted by something next to it. Then I can cancel out these x minus 1s and I cancel out these x's. So what am I left with? Well, I have a 4x minus, right, 6 times x minus 1. So that's the numerator. That's the new numerator. It's no longer a fraction. It's no longer in rational form. And then the denominator is x plus 8 times x minus 1. Okay. And then what I can do here, so basically this method allows you again to get rid of all of your fractions. And now I can just focus on simplifying. So on the numerator here, I have 4x minus 6x plus 6 when I distribute this guy, right? And I distribute this negative 6. And then in the bottom here, I'm going to distribute 8. Okay. So this is x plus 8x minus 8. Now, some people will want to like subtract these guys, like 4x minus 6. You can't subtract them. They're not like terms. Okay. You cannot add x and 8. They're not like terms. Okay. But the 6 is directly next to the parentheses. That means it's being multiplied by this entire thing in parentheses. The 8 is directly next to the parentheses. It means I'm multiplying 8 by everything in the parentheses. And then now at this point, I just combine like terms. So I have 4x minus 6x, which gives us negative 2x plus the 6, which did not have a like term. And then I have the x plus the 8x is a 9x minus 8. Okay, so this is an acceptable answer. You could also have this guy, you see the numerator, I could factor out a negative 2. So this would also be an acceptable answer as well. Okay. Now I promised you, so this is the last problem. I promised you that I would go back to that homework problem and use method 2, okay, to simplify this. So this is kind of a more common problem that you would see. Some of those are maybe a little bit too difficult. But again, with this method, the thing that you have to do is you have to find the LCD. Well, what's the LCD of all of your denominators? Well, your only denominator really in these rational expressions is x. So the LCD is x. So what I'm going to do is I'm going to multiply this numerator by x, and I'm going to multiply this denominator by x. And when I do that, I have x squared divided by 7x over x plus 7x over x. Okay, so we distribute this x into both of those rational expression terms there into the numerator. And then from here, I can cancel out the x's. And so what am I left with? I'm left with x squared on the top over 7 plus 7 on the bottom, which is just simply 14. So I get the same answer that I got before, and you guys can go back a few slides. I got the same answer as using method 1. Okay, and method 1 was adding these 7 over x's first together. Remember, we got x over 14 over x, and then we did x divided by 14 over x, and we multiplied by the reciprocal. Okay, so we switched the 14 over the x to x over 14, and we still got that same answer of x squared over 14. So either method works. You guys can choose the method that works best for you. Okay, I'm not going to force you to do, one of the methods. But if you have questions, please ask me. I know this section in particular gives students some trouble. So reach out if you have questions, view those extra examples, watch my lecture video and videos, watch the Pearson videos as well. They probably have some more tips that I didn't include, as always. And then again, reach out if you have questions. So I'll see you next time for section 7.6.